to my YouTube channel, and in today's video I'm going to show you how to build and deploy a staking contract, a Masterchef staking contract on Aptos. So if you're not new to DeFi, then you know that one of the most basic aspects of DeFi, decentralized finance, is yield farming, staking, and stuff like that. And one of the most popular type of staking contracts in DeFi is the Masterchef contract. It's one of the most forked uh, staking contracts ever built. Popular protocols like PancakeSwap, SushiSwap, and many others make use of the Masterchef type of smart contracts for their staking and yield farming. So in this video, we're going to try to implement Masterchef using Move and deploy it on Aptos. So before I continue, I must state that this is going to be a rather long video because we're going to be writing about 1,000 lines of code, both functions and tests included. So you might want to brace yourself up for this, and most likely this video is going to be in two parts because it's going to be too long and I don't want this to exceed maybe 20-30 minutes. So if it exceeds that, we would have to break it into two different parts. So let's begin. So first things first, we would have to initialize our move package. So I already created a folder for my move package, so you can do that on your own and then cd into that folder. So I'm here already. So how to do this? First of all, would first of all have to initialize Aptos in our CLI so that we can have an account to work with. So we'll do this by writing Aptos init. So since this is just a tutorial, I'll be initializing a random account. I don't need an account that I have access to. I'll just initialize a random account and airdrop some tokens to myself so that I can use it for deployment. So we just created a random account, a new account on Aptos. So here's the details for the account. We have private key, public key, and account. So I'll probably never use this account again. So we'll just use this for this tutorial. So I'll just copy my account address and then let's initialize the move package itself. So run Aptos move init name, and we'll call this Masterchef staking. Alright, so we have our move package initialized, and here we have our move.toml. So I'm going to add a new feed for addresses because we need an address to deploy our move module. So we're going to name this address, which is the address we generated from the Aptos CLI. We'll call it the deployer address. Alright, so here we can write our move code inside the sources folder. So I'm going to create a file, call it masterchef.move. So here we can write our move code. So first things first, we would have to declare the address under which we are going to deploy the modules, and then we would write our module inside. So the name of our module be Masterchef. So next thing we have to do is to import some useful modules that will be using their functions inside the contract. So first thing to do is to import the signer module. Use std signer, and then the string module. Use std string, and then a more specific function from the string module, utf8. Right, so let's also import the type info module. So we'll be using the type info module itself, and also type info struct from the type info module. Then let's also import the events module. And also the vector module. And we're gonna need the Aptos framework here. And we'll be importing the coin module from Aptos framework. Let's also import a few other modules from Aptos framework. So here would import timestamp. Of course, this is a staking contract, so we want to be able to keep track of block time. So we'll be using the timestamp module from the Aptos framework, and also last but not the least, the Aptos framework account module. So the reason why I'm importing both account and event is that a few changes were made to the Aptos framework, and some functions from event no longer work. Some of them are found in account, so we might need them. I don't know yet, so I just imported it just in case we need them. And if we don't need them, then I'll delete them at the end of the video. So the next thing after importing our libraries or use modules is to define some constants. Our first constant will be errors, so let's define some errors. So our first error is forbidden. So next error would be LP token doesn't exist. So the Masterchef contract can support both single tokens and LP tokens. That is, it can support just fungible tokens and then liquidity provider tokens from exchanges. So let's although we'll refer to all tokens that are deposited in the Masterchef as LP tokens. Then let's write one for, sorry, let's add an error here so that readers can understand that these are all error messages. So let's add another error for when LP token already exists. U64 105. Then insufficient amount. Okay, U64 and then 106. Okay, so let's add some constants. So we're going to be deploying both the token for the Masterchef, the reward token. We're going to be deploying both the reward token and the Masterchef contract itself within this code. So I know normally you would have the token itself would have its own contract and then the Masterchef contract separately, but in this case we want to deploy both of them together because this is just a tutorial. But maybe probably in a production environment you might want to deploy them separately. So we're going to call our token the chef token. So let's write a struct for our token. I'll call it the chef token. But before we continue with that, let's write some more constants. So write a constant for the precision of our chef token. Which is basically the decimal places. And 128. So you can have 18 decimal places, 6, 7, 8, 9, 10, 11, 12, but in this case we'll leave it at 12. All right, so one more thing, let's write a constant for the deployer address, because we're going to need it in several places in the code. So let's just declare it as a constant. All right, so now we can continue. So before we go further, let's just run some unit tests just to be sure that we don't have any issues with our code. Aptos move test. All right, so all we get here are yellow warning messages, and when you get the yellow warning messages, just know that you're not doing anything wrong yet, because these are basically just warning messages to tell you that you have some libraries or some use modules imported that you've not used yet. But if you don't intend to use them, you can remove them. But if you intend to use them, you can just continue writing your code until you get to where you need to use them. So let's continue writing. So we'll write another strut for capability. So here caps has key, and then we'll write some more details. So direct mint would be a boolean value, will be true or false, and then mint, we have coin mint capability for chef token, and then freeze would have freeze capability for chef, and then born would have born capability for chef. Now these are basically structs within the coin module from Aptos framework. So we use these ones to we use them to define capabilities for tokens. So let's write some more struts. Let's write a strut for event. So we say event has keys. Add event. So we're going to use the event module from the one we imported earlier. Event handle. Alright, coin metadata, then set event. Now if you don't understand anything in the code, you can always drop a comment at the comment section. And by the way, if you're new to the channel and you're learning from what I'm doing here, if you like, you can leave a like on this video, and you can also consider subscribing to this channel and turning on the notification so that you get you'd get notified when new videos are uploaded on this channel. So here we also have an event handle, coin metadata. Okay, add a comma here. So we have a deposit event. So the add event is basically for adding new pools to the Masterchef contract, and then the set event is basically for setting pools in the Masterchef contract, and then the deposit event, like the name implies, is an event for depositing tokens to the contract or to the module. So we'll have the deposit event. So we're going to have to write these structs later. I'm going to write it at the top. So we have the withdraw event. Like the name implies, the withdraw event is an event that occurs when someone withdraws from the contract. And then we have emergency withdraw event. Now remember, we are building this after the model of the original um, Masterchef contract, which is on EVM. So we are trying as much as possible to replicate all the functions that we have on the original Masterchef contract. So we have a few structs here that are not yet defined. We have coin meta, we have deposit event, and we have withdraw event. So let's define those structs before we continue. So strut. So basically this strut would set or add event data. So let's continue. So this has drop, store, and copy. So if you want to know what these keywords drop, store, copy stand for, you can refer to the official move documentation. I don't want to go into that now, so we don't waste much time. So here we have type info for and then allocation points. Now if you already know about Masterchef on EVM, then allocation points shouldn't be strange to you. So let's try to run a unit test. Of course we'll get an error because we've not defined the withdraw event and the deposit event yet. So the next thing we'll do now is to define the deposit event and withdraw event structs. Deposit event. This has drop and store. So we have the sender address, which is an address. Use the address keywords to specify addresses in move, and then coin type. Use type info from the type info module, and then amount, the amount which is being deposited. So whenever you're writing amounts in move, especially in on Aptos, not necessarily in move, because different blockchains that are running the move EVM, the move VM rather, have different frameworks. So when you're writing code for Aptos, always remember that the amount should always be specified in U64 numbers, because that is what is available in the Aptos framework. Even if you are working with U28, you also have you have to find a way to convert them to um 64. So we've written deposit event struct. So let's write the struct for the withdraw event. So just like the deposit event, the withdraw event has drop and store also. So we're just going to copy everything from the deposit event, because the withdraw event is just an inverse. It has the same parameters also. So here, let's run our unit test once again. Alright, so now we are back to just yellows, and alright, so we've successfully written a few structs for the contract. So let's write some more structs to define some other events. So here we're going to write the user info struct, and basically this struct is just the info of each user that is stored at the user's address. Basically this makes sure that people don't withdraw more than what they deposited. It just keeps a record of what each user has deposited or withdrawn from the contract, so that you don't have somebody depositing maybe 20 tokens and then coming back to withdraw 500 tokens. I'll just write it in the comments here. Stored at users address. Alright, so struct user info, so we're gonna assign a phantom type, which is the coin type. Since we are not only depositing just one type of coin in the staking contract, we are depositing any coin can be deposited on the contract as long as a pool has been created for it. So we're going to leave this as a generic coin type. So this has key, has store, and copy. So we have the amount and the reward depth. Once again, if you already are familiar with the original Masterchef contract, then you know that this does not in any way, it's not in any way different from the original Masterchef contract. This is exactly the same struct for user info that you would have in the original Masterchef contract. We are just trying to implement it in Move and deploy it on Aptos. So here the struct for the user info just contains the amount the user deposited or withdrew, in which case, in depending on the situation, and then the reward depth. So this is basically how much he is owed by the contract, or how much they can withdraw from the contract when it is time to withdraw. So let's write another struct for pool info. So this is basically the info of each pool. User info is the info of each user, while pool info is the info of each pool. You want to keep track of all the pools so that you don't deposit BTC in the pool that's meant for ETH. this has key and store. And then we'll have last reward timestamp. Then allocation points. Alright, so let's run this again. This part will just basically write all the structs and start writing the functions in the next part. So let's write another struct. Basically, structs store information, so don't be carried away with the name struct. So master data as drop and key. Okay, so the signer cap, signer capability. Okay, I think we didn't import that here, so we'll just do that. Self signer capability. Right, so let's go back. And then total allocated point. Will be a U64 number. Then admin address. Then we're going to add an address, that the dev address, or if you want to call it the marketing address, let's just call it, since we already have admin address, let's call this marketing address. So in the normal or rather the original Masterchef contract, a certain percentage is sent to the admin and a certain other address called the dev address whenever tokens are minted. So that's what we're trying to replicate here. Or better still, if we want to make this look more bullish, we can call it the DAO address. And then the percentage that should go to the DAO address. It should be a U64 number also. And then bonus multiplier. Last timestamp for DAO withdrawal. Then starting time, the time at which rewards would start counting, and then per second. So the original Masterchef, although there are now many variations of the Masterchef contract, the original Masterchef actually mints tokens per block depending on the number of blocks. So you can set it to mint maybe 20 tokens for every block, or for every 3 blocks, something like that. But since we still don't know the block time of Aptos, and we can't count on that to determine emission rate, so we'll go with a per second count. So we'll determine the number of tokens that will be emitted every second instead of per block. Let's make this a 128 integer. Okay, we're almost done with struts, so let's define one more strut, and that'll be all for this part. LP info so this would return list of all added LPs. And LP list will be a vector of type info. And that will be all for the structs. So we've written all the structs that are needed to store information or to store data in the contract, and we're just at 83 lines or 86. So in the next part of the video, I'm going to start writing the functions, and we'll see how to implement our favorite Masterchef functions in Move. So if you learned something from this video, consider liking the video and subscribing to the channel. Turn on your notifications so that when I upload new videos, you get notified and you'll be one of the first to watch them. So see you in the next one.